3 notes. We're going to start off with the change of base. And the change of base, if you have the newer calculator, this is really fairly trivial. But if you have the TI-83, you need this. If it's log x base a, you can do ln x divided by ln a, or log the log button on your calculator x divided by log a. So let's look at example 1, letter A. And I just went 2 decimal places. So if I want to do log 17 base 3, let me pull my calculator up. And that would be like ln 17 divided by ln 3. Or, if you have the newer calculator, you would press math. There we go. So then it'll do it for you here. I thought, what did you guys say?
Alpha A. Like
okay, I think there's an alpha. If you do alpha window, do you see it's right there? Oh. What? Yeah. If you alpha window will do it too. Okay. Okay, so I'm getting 2.58, and this one I'm getting 4.39. All right, properties of logarithms. Our book uses u and v. So the log of u times v base a would be log u base a plus log v base a. That's called the product property. Then we have the log of u divided by v base a. So that's log u base a minus log v base a. And then we have, that's called the quotient property. And then the third one is the power property that says if you have the log of u to the n base a, that equals n times log u base a. All right, example 2 says write the logarithm in terms of ln2 and ln3. So if you look at letter A, it says I have ln6. Okay, well that's a 6. How can I create an ln with a 2 and an ln with a 3? And tie it into your product property. Any ideas? Ben?
ln2 plus ln3.
Okay, can you back up one step for me? That's the final answer. How did you get there?
I just typed in ln6 on my calculator and what I said, and it was the same.
Okay.
First property.
Yes, it is the first property. If you think about it, 6 is 2 times 3. So ln 2 times 3 is the same thing as ln 6. And then you're right, it's ln 2 plus ln 3. All right, then let's look at part B, ln 2 over 27. Well, the first thing I would notice is I can use that quotient property and say that's ln 2 minus ln 27. But I don't have an ln 3, and I didn't want an ln 27. But what do you know about 27? It's 3 cubed, right? So this will be ln 2 minus ln 3 cubed. Do you notice that still isn't an ln 3? It's an ln 3 cubed. So we can now use our product property, not our product, our power property, and bring down the power. Now I have ln 2 and ln 3, okay? All right, example 3 says use the properties of logarithms to verify that -1 times log 1 over 100 base 10 is equal to the log of 100 base 10. All right, any ideas? Yeah, Seth?
First, you move the -1 in front of the log,
the power of 1 over 100.
Good. And did you guys remember that if you have log base 10, you don't have to write the base 10? And then what do you know about 1 over 100 to the negative 1 power? It flips. So right here I can stop because they're the same, or you could say 2 equals 2. What? How is that 2 equals 2? Because log
10 to the 100 is
100 base 10 to what power is 100? It's 2. Alright, example 4 says expand the logarithmic expressions. In letter A, I have log 5x cubed y base 10. So I'm going to drop the base 10 because we don't have to write it. And I'm going to first use that product property that says that's the log 5 plus log x cubed plus log y. And then I have an exponent on the x, and so I can bring that down. I just have a word of caution here. Sometimes I'll see students who see that x cubed and they bring the 3 out front and then say it's 3 log 5 plus log x plus log y with either a big parenthesis or just in front of the log 5. You understand that that 3 is not around everything there. So you can't bring the exponent down until you have the x cubed alone inside the log. Alright, letter B. What I would probably do is change it to a quotient so that I have ln square root 3x minus 5 minus ln 7. Now, a square root, remember, is a 1/2 power. So you can bring the power down. Again, you don't bring that power down till you have it alone. So you can't say it's 1/2 times that difference. Okay? Now I want you to pause here a moment because this is really tempting for students. They want to try to do something with ln, the quantity 3x minus 5. And I want you to look back at your 3 properties. Do any of the 3 properties have an ln u minus v? An ln with a u minus v inside? No. So having, and this ties into our exploration with number 1, students like to say ln x plus 2 is ln x plus ln 2, but it's not true. Okay? Alright, so the opposite of expand is condense. And so I strongly recommend that in order to do this, you deal with your exponents first. Because I don't mind if you know how to do multiple steps, but if you're doing them incorrectly, then that's not working for you. So be careful. If there's a number out front, bring the power up. And then I'm going to do 2 things here. X to the 1/2 is a square root. So this is actually the log of the square root of x times the quantity x plus 1 cubed. Alright, any questions on part A? Alright, try B. I'm going to give you a head start on me. Okay, check it up here. First, you bring the exponent up, because do you understand that if you try to do the difference first, you'll get it wrong, that this 2 is not in front of that difference. It's only in front of the x plus 2. So you bring it up, and then it becomes the quotient, x plus 2 squared over an x, not an x squared. Those are different. All right, any questions?